Section 8.5, factoring x squared plus bx plus c. Prime factorization is where you list the prime factors that make up a number. So remember, when they ask you for factors of something, they're talking about numbers that multiply together to give you that particular number. So for 12, those options are 1 and 12, 2 and 6, 3 and 4, 1, 4 and 3, or 2, 2 and 3. All of these combinations multiply together to give you 12. Prime factorization means talking about the prime numbers that make up that number. So in this case, 2, 2, and 3 make up 12. Greatest common factor, or GCF, is the biggest shared factor of a group of terms. So the factors of 12 are 1, 2, 3, 4, 5, 6, and 12. The factors of 32 are 1, 2, 4, 8, 16, and 32. The largest number that 12 and 32 have in common is 4. So the greatest common factor is just 4. We're going to use this information and apply it to factoring polynomials. So we want to find the GCF of each pair of monomials. So we want to think about the greatest common factor between 15 and 9. Well, what number goes into both 15 and 9? Well, we can think about this by listing them out this time, so we know 1 goes into 15, 5 goes into 15, well, let's go in order. 3 goes into 15, 5 goes into 15, and so does 15. Then for 9, we know in 9 you've got 1, 3, and 9. The largest common factor between the two is 3. So the coefficient's GCF is just 3. But then you have to look at the variables, and you have to ask how many variables do these two, or what exponent power do these two variables have in common? Well, this first variable has essentially 3 x's. It's x times x times x, where the other one is just 2 x's, or x times x. So think about the most, or the greatest number of x's you can take from both quantities. In this case, it'd just be x squared. So our GCF for these two terms is just 3x squared. We want to do the same thing here. Our first term is just, this one just breaks down to 1 and 5. For 25, we're looking along the lines of 5 and 5. And then 45, so we have to have something in common, so let's think 9 and 5. So all 3 of these coefficients have a 5 in common that we can take out. So we're going to have a GCF of 5. And then we look at our x values. Well, we've got x cubed, x squared, and then x. So the most x's we can take out from any of the 3 terms is just an x to the first. So our GCF becomes 5x. To factor using the GCF, you first want to list the prime factorization and find the GCF. And then you factor it out and list what is left. All right, so this is a 2-part piece here. So let's look at the first example. We've got 8x cubed minus 4x squared minus 16x. Well, right off the bat, I know that 8, 4, and 16 all have a GCF of 4. And then x cubed, x squared, and x have a GCF of x. So our greatest common factor is just 4x. So when we go to factor this, we're going to take 4x and we're going to put it outside parentheses. And essentially what you're doing with this is we're now going to take this original statement and we're going to divide every term by the GCF to figure out what goes back in the parentheses. So 8 divided by 4 is 2. And then we're going to subtract the exponents on our variables. So x cubed minus x becomes x squared. Negative 4 divided by 4 is negative 1. X squared minus x is just x. And then negative 16 divided by 4 is negative 4. And then x and x just cancels out. So our factored form becomes 4x times the quantity 2x squared minus x minus 4. Let's try another one. We're looking for our GCF first. So GCF, we've got 9, 15, and 12. Well, I know that they all have 3 in common. x to the 6th, x to the 4th, and x squared have x squared in common. And so now I'm going to go about factoring this. And to remember, to factor this, I've got to essentially divide each term by the GCF. So I've got 3x squared, parentheses, 9 divided by 3 is 3, x to the 6th, x squared becomes x to the 4th, 15 divided by 3 is 5, I take 4 minus 2, I've got x squared, and then 12 divided by 3 is 4, and 2 and 2 cancel out, so this becomes my factored form. 3x squared times the quantity 3x to the 4th plus 5x squared plus 4. We're going to do the same thing here. We've got to find the GCF first. So I've got 4, 24, and 8. So the GCF for the coefficients is 4. I have a w that I can take from each term. So I've got 4w as my GCF. So I'm going to divide every term by that GCF. So I've got 4w, and then 4 divided by 4 is 1. W to the 5th, subtract 1w, or w to the 5th divided by w gives you w to the 4th. So we subtract the exponents, and then negative 24 divided by 4, negative 6. Subtract your exponents, you've got w squared. 8 divided by 4 is 2. Subtract your exponents, so the w's just cancel, and this becomes our factored form. This time we have negative 6b to the 4th minus 18b cubed minus 12b squared. So we're going to find our GCF. 6, 18, and 12 all have 6 in common, but I'm going to pull out a negative 6. Since they're all negative anyway, it'll make the numbers inside positive when we're done. And then b to the 4th, b to the 3rd, and b squared, I can take out a b squared. And so now I'm going to factor this. So in this case, I've got negative 6b squared on the outside. Negative 6 divided by negative 6 is a positive 1. And then I've got to subtract the exponents, so I've got b squared. Negative 18 divided by negative 6 is a positive 3. Subtract my exponents, I've got b. Negative 12 divided by negative 6 is positive 2. Subtract my exponents, the b's cancel, and I'm left with negative 6b squared times the quantity b squared plus 3b plus 2. We learned how to multiply two binomials using the distributive property, or the FOIL method. In this lesson, you're going to learn how to factor a trinomial into the two binomials that created it. Factoring is essentially undoing the multiplication done through FOIL. In order to factor a trinomial, you're going to essentially look for the factors of your C term that add up to be your B coefficient. All right, so we're looking for the factors of the last term that add up to be the middle term. Here's some helpful hints. When C is positive, its factors have the same sign. The sign of B tells you whether the factors are positive or negative. If B is positive, the factors are positive. If B is negative, the factors are negative. So remember, if C is positive, both of the signs have to be the same for your two factors. So for the first example, we've got x squared plus 6x plus 9. We're looking for the factors of 9 that add up to be 6. So if we didn't know how to start this, we could just start by listing out the factors or numbers that multiply together to give you 9. Since 6 is positive, both of our factors need to be positive. So we've got 1 and 9, or 3 and 3. The two factors that multiply together to give you 6, that add together to give you 6 are 3 and 3. So what happens now is these are our two factors, and so to create our two binomials, we take and we put an x in one parentheses and an x in the other, and then we're just going to input our two factors. We put plus 3 here and plus 3 here. So these two binomials, when FOILed, create this trinomial here. All right, so let's do the same thing in the next example. We're looking for the factors of 40 that add up to be negative 13. because the 13 is negative, both of our factors need to be negative. So we're looking at -1 and 40, -2 and 20, let's say -10 and 4, -4, and let's say -8, -5. The factors here that add together to give you -13 would be -8 and -5. So we create our two binomials. We end up with x minus 8 and x minus 5. And so this is the binomials that create that trinomial. Example 3, same thing. We've got x squared plus 8x plus 12. We're looking for the factors of 12 that add up to be a positive 8. So you've got 1 and 12, 2 and 6, 3 and 4. Of these that add up to be 8, we've got 2 and 6. So that means our factored form becomes x plus 2 and x plus 6. In the fourth example, same idea, factors of 24 add up to be -11. So they both have to be negative. So we've got -1, -24, -2, -12, -3, -8. Well, I think we've got a winner here. -3 and -8 add up to be -11. So those are our two factors, and so our factored form becomes x minus 3 and x minus 8. All right, so when c is negative, its factors have opposite signs. All right, so if the sign, so in this case, the sign of b just tells you which of the factors is larger. All right, so if your b value, when your c value is negative, is positive, that means the positive factor is the larger number. If it's negative, that means the negative factor is the larger number. So here we've got x squared plus x minus 20. We're looking for the factors of -20 that add up to be positive 1. So remember, they have to be, one has to be positive, one has to be negative. 1 and -20 and -20 and 1 don't really work here. So let's start a little farther down. So let's say -2 and 10, -10 and 2, -4 and 5, and -5 and 4. Of these, we're looking for the ones that add up to be a positive 1. So that would be -4 and 5. And so we go ahead and factor this out. We've got x minus 4 and x plus 5. In the next example, same idea, x squared minus 3x minus 18. And we're looking for the factors that add up to be multiply together to be -18, but add up to be -3. So let's say -18 and 1, -1 and 18, -6 and 3, -3 and 6. And I think we passed the one we wanted. -6 and 3 add up to be -3. So these two will work. And so we factor it out. We've got x minus 6 and x plus 3. And so this is our factored form.